Hi team, we're about to start section quadratic functions. A quadratic function is a polynomial that has a highest variable exponent of 2. In its general form, it would look like this, where A, B, and C are constants. So we know it's a quadratic because the highest exponent that we see on a variable is a 2. So let's take a look at some of the important characteristics of a quadratic. The one that is graphed here is a quadratic that's opening up, a parabola. It looks like a bowl. It can also open down like an umbrella. So the first thing that we can do is to determine, here are the characteristics down here, to determine if a quadratic is concave up or concave down is if A is positive, then it's going to open up. That leading coefficient, if it's positive, it opens up. If A, that leading coefficient right here in front of X, if that A is negative, it's going to open down. Remember how to find x-intercepts? We're going to plug in y for 0. And for parabolas, there are 3 possibilities. We can have 2 x-intercepts here and here. We could have 1 intercept if it only crosses the x-axis once. Or it's possible that it doesn't cross any x-intercept. So we can have 2 x-intercepts, 1 x-intercept, or no x-intercepts. For the y-intercept, we plug in x equals 0. This is where the parabola crosses the x-axis. Now, the vertex or maximum or minimum, if we notice our pictures here, it would be the lowest point, so a minimum if it is opening up, or it'd be the highest point or the maximum if it's opening down. So you can visualize if it opens up, you're going to have a bottom point. If it opens down, you're going to have a top point. These points or turning points where it changes directions is called the vertex. So in order to find the vertex, we are going to use the A and the B value to find the x coordinate. Now the vertex, we usually use H and K instead of X and Y, just to say this is representing our vertex. So to find the input or the H coordinate, we take the opposite of the B value and divide it by 2A. And then to find our K value, we plug in that H value into our function, or find the function value of that negative B over 2A. So once you find the input for our vertex, you plug that in and find the output of our vertex. And again, if it's opening up, then that vertex is going to be a minimum. And if it's opening down, that vertex is going to be a maximum. Looking back again at our picture, the axis of symmetry is an imaginary line that splits that parabola in half. That parabola is going to be a mirror image across that axis of symmetry. And notice that axis of symmetry always goes straight through your vertex. It is a vertical line. So to find your axis of symmetry, you're going to have x equals h. Simple enough, right? Axis of symmetry, and you can write yourself a note where h is the input value of your vertex. So axis of symmetry, once you find your vertex, you can always find the axis of symmetry. Just be sure you have the x equals because it is an imaginary line. So it needs to be the equation of a line. Now, also, if we look at the leading coefficient of A, so the larger the absolute value of A, the more narrow the parabola becomes. The smaller that leading coefficient is, the wider the parabola is. So narrow versus wide. Think of it as it being stretched up or squished down.